Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is, walls coloring. So, without any further ado, let us get started. So, before that, let me just present my screen. Yep. So, I think this is fine enough. Yep. This orientation looks better. And okay, we would talk about it. Okay, so just let's go back to this problem. So, in this problem, we are told that we need to paint n rows. Okay, so basically, suppose there are one, two, three. Okay, we need to paint three walls. Okay, on the occasion of New Year, and each can be painted with three colors. Okay, so let us write this in white so that everyone would make sense. Okay, so now each one can be wrote with a yellow color and a black color. Black color is not possible. Okay, sorry. So each one can be painted with a black, pink, and yellow. Okay, so we need to basically paint all the walls, and each wall can be painted with black, pink, and yellow. So let us first acronym this: black as B, pink as P, and yellow as Y. So now it says that suppose I have painted the suppose I have painted the second wall with the blue color, then I can paint the third wall with the next two colors. That is, so suppose this is the black color, so I can paint the next two walls with pink and yellow. So pink and yellow. Where this is mentioned in this. Okay, you need to find so that no two adjacent walls have the same color. It is written at this point. So I can say that if the last painted color is pink, then I can have blue and yellow. If the last painted color is yellow, I can have blue and I can have pink. If the last painted color is blue, then I can have P and Y. If the last painted color is Y, then obviously I can have B and P. If the last painted color is B again, so I can have P and Y. And if I have P, then the last one would Y and B. Because it is told that the subsequent values, that no two adjacent values should have the same value. Okay, so if I start off with blue, then this would be the combination from the top to the bottom. Okay, now let us go back to this figure. Now it is told that if I paint with pink, this would be the cost. If I paint with 14, this would be the cost. If I paint with 10, this would be the cost. So basically, these are the cost. So here it is told that I would paint the first wall with the black value, that is 2, and the next value with 5, and the third value with again 3. So 2 plus 5 plus 3 is equals to the value 10. That is why the output to this is 10 itself. So am I clear with the problem statement or not? So basically ट्रांसलेटिंग द सेम इन हिंदी वुड बी, हमें 3 कलर दिए गए हैं और n वॉल्स दिए गए हैं और हमें ये बोला गया है कि अगर पिछला वाला और अगले वाला दोनों सेम नहीं रहना चाहिए. दिस जस्ट सेज दैट वी हैव 3 ऑप्शंस, pink, black and yellow. If we have 3 options and we have used this one, Then in the next move, we have the remaining two options. We don't have this option again. Why? Because this option again means the adjacent would be the same one, and it would be the non-respect of the given condition. So am I clear or not? Give me a quick one in the chat. Which tool you are using for recording the video? Basically, I'm not recording the video, I'm currently streaming the video. But talking about the recording of the video, I generally use OBS for recording. Okay, so I think we can move forward. So yep. Okay, so now if you move forward, you would see that basically we have a kind of choice diagram where the first one has 2 to the power 0 node, the second one has 2 to the power 1 node, and third one has 2 to the power 3 node, and the fourth one has 2 to the power 4 node. So this easily tells us that we easily come to the conclusion that this problem is of recursion. Okay, this problem is of recursion with a time complexity of 2 to the power n. How? Because at each point we have the number of nodes as 2 to the power 0, 2 to the power 1, 2 to the power 3, 2 to the power 4, till 2 to the power n minus 1. That is why we can say the time complexity of this approach is 2 to the power n. Okay, so first let us just implement this itself. Okay, how we would implement, we can say just like this diagram, we can say that the last use, like let's talk about this. Okay, let's talk about three walls. Okay, suppose if we have three walls and the last painted color, so first suppose we have three walls, so there are three options. First is blue, first is black, the first one is black, the next one is pink, and third one is yellow. So if we start off with blue, then the next one we can paint off with is pink and yellow. If we start off with pink, then the next we can start off is blue, black, and yellow. If the last painted one is, suppose the first painted one is yellow, because the first we start painting. Okay, we start painting, so the options we have is that we either can paint the first one with blue, pink, or yellow. So if we paint it with yellow, then the next option we have is blue and pink. So if we talk about the third one, okay, so basically let's talk about the third one also. So if we talk about third one, if the last one was P, then we have B and Y left. If the last one was Y, we have B and P left. If the last one was B, we have P and Y left. If the last one was Y, we have B and P left. If the last one was B, we have P and Y left. If the last one was P, we have B and Y left. So we can simply say that we need to start off with the given three scenarios that we have, because we can start off with the first given three scenarios, either paint the first one with blue, paint the second one with paint the first one with blue, black, pink, and yellow. Okay, fair enough. So now what we can see is that basically if we are just we what we need to do is we are saying that yes, this is the black one. So we would move forward with the rest two approaches. If we are moving forward with the rest two approaches, we would have, if we have three options and if we have used one, then we have remaining two. And the minimum of them would give me the answer because minimum is required. So minimum of left comma right would give me the answer itself. Okay, fair enough. So now what we can say is that in rec, and the last use color is, let's suppose, color. Okay, and we would say if the last used color is, So let me just make it this. First, tell me if this thing is clear or not. Can I start coding the recursive approach or not? Give me a quick one in the chat. First, give me a quick one in the chat if the explanation is clear or not. Like I'm just talking about the recursive approach, no DP or something. I'm just talking about the recursive approach, no DP or something. Okay. So now let's suppose. So let me just talk. Okay, let's keep this. Okay, I'm clear. So let's talk about the recursive approach. Suppose this is the color I, color C, and this is the index we are standing at this current position. Okay, so if the index is equals to 0, like let's talk about the base case. So base case is the smallest case that we can handle by ourselves. Okay, we can handle by ourselves. If the smallest case is that I would use the color yellow and there is only one block. So block is 1. Okay. So n is equals to 1 and I would use the I would use the color C. Like the value of n is 1 and I would use the color C. So it just means that if I is equals to 0, sorry, if the value of n is equals to the value 0. Okay. If like n is equals to 1, if n is equals to 1, that means the index value would be equal to 0. Okay, because one element means the indexing would stop. Like if suppose there are 5 elements, then the indexing would be 0, 1, 2, 3, 4, not 5. So if I is equals to 0, that means 1 point is left. So what we would say, return. So here we would say col. Okay, return col. Okay, return col of 0, comma 0. This the first one is of which color? The first one is of pink color. Okay, walls, each wall with either pink, black, or yellow. Okay, so if C is and so I is equals to 0 and C is equals to so 0. So let's make a convention that 0 is equals to pink. Okay, 0 symbolizes pink, 1 symbolizes black and yellow. Okay, fair enough. Just remember this. So if the color is pink, then we would return the first one. If the same condition is repeated and this time the color is 1, so I would say the last painted color was 1, 0, 0, 0, 1. Okay, and if the second condition that the color painted is 2, then I would simply say yes, this is yours. Or suppose there is one block and I want to use the pink color. So I would say, okay, see, keep it here because the adjacent part is removed only. In one element, there is no adjacent element, so we don't need to care about anything. So if I want to paint with the color 0, I would say, yes, this is the cost you would encounter. If I want to paint with the color 1, I would say, yes, this is the cost. अगर मुझे लास्ट वाले कलर से सपोज ब्लैक से पेंट करना तो बोलूंगा हाँ ये लो क्योंकि एक एलिमेंट के बगल में तो कोई एलिमेंट है ही नहीं तो एडजेसेंट का मुझे सोचने का जरूरत ही नहीं है ओके now I would come here if the number of elements are more than 1. If we have the number of element more than 1, what we would do? So if the color C is equals to 0, if color C, first we would initialize the answer. We would initialize the answer at this point. And we would say if the color C is equals to 0, then answer is equals to minimum of rec of rec of C, let of, like C is equal to 0. So it just means that suppose I want to paint the color current one with 0. That means that I want the previous answer. Like suppose currently I want to paint with pink. Then I can only paint with black and yellow. So pink was what? Let's suppose pink was 0. Yes, it is given pink as 0. So black is 1 and yellow is 2. So here I would say that rec of 1 and n minus 1, comma, rec of 2 comma n minus 1. And if I am painting with the color pink, then I would encounter the cost of that also. Call of 0 comma 0, I comma 0. Okay, fair enough. Suppose I want to paint with the color pink, then first I would encounter the cost of painting it. Then the minimum of painting it with yellow and blue, because the rest color is this. So now I would say if C is pink, then minimum of black and yellow. Simple. If C is pink, then minimum of black and yellow, and then cost to paint pink. Simple enough. Now here, from this point, what I would say is, if suppose I want to paint, suppose I want to paint with the color 1, then I have the option of painting the color with 0 and color with 2. And here at this point, suppose I am painting with the color 1, so I would paint the color 1. Now, if I'm painting with the color 2, then I have the other two options. Okay, so if I'm painting with 2, then I have 1 as well as I have 0. Okay, and this one would be 0, 1, and 2. Okay, and all of this n would be I. We don't have anything as n. Okay, this is done. At the end, we would simply return the value of the answer itself. Okay, so this was the recursive code. So quickly give me a yes or no if I'm clear with the recursive code. And there is no point in submitting this code because we would definitely get a TLE, because the time complexity of recursive approach is 2 to the power n, which is exponential. So give me a quick yes or no in the chat if I'm clear. Like, am I clear with the code of recursion or not? Sir, we have to give, and then why are we checking the color, every color at I is equals to 0? I is equals to 0. Where I is equals to 0? 1 and 2, 0 and 2. I is equals to 0 is the base case. Like if we have only one thing to paint, if we have only one thing to paint and we are painting it with the first color, then the cost encountered is this one. Like these are the base cases and these are the recursive case. Give me a quick yes or no. Astha Tripathi, am I clear? Give me a quick yes or no. Hi Nakaj, how are you? Give me a quick yes or no if I'm clear. Astha Tripathi. Okay, so I think Tripathi is not present up till now. So I would simply unshare the screen. Okay, I think I'm good to move forward. Okay, so we are telling that then it should be the minimum cost among all. No, it not should be the minimum cost. Why? Suppose I want to paint suppose there is only one block. Suppose there is only one block, and I said you that the adjacent color should not be same. But as there is only one block, so there is no point in adjacent or something. This is the very first thing. Now suppose I told that I want to color this pen with black. So if I want to color this pen with black, then I would encounter the cost of black. That is why I am telling you that if there is only one element, I is equals to 0 means what? That the value of n is 1 and I is 0 because the index is 0. And if I want to paint it with 0, then I would encounter a cost of 0. If I want to paint it with 1, I would encounter the cost of 1. If I want to paint it with 2, I would encounter the cost of 2. But this would only happen, like suppose I want to paint this color with black, blue, pink, white, anything. I can paint it with anything. Why? Because there is only one element. But suppose if there is one more element at this point present, then I need to take care of this element color also. So irrespective of that, I can just take the value. Suppose I want to do this, I want to do that. And I would say that for index I, this would be the minimum of C1 to 012. And yes, for index 0, I would take the minimum of 012. C is equals to 012. You are also correct, but I'm just telling you more. We are recursing from n minus 1 to 0 index. Right. Yes, absolutely right. Okay. So now this thing would become more clear when we would copy the same conditions in the given iterative one. Okay. So now we would say, okay, now we would say that int dp of n plus 1 of size 3. Why? To store the values of 0, 1, 2. See, the number of dynamic variables c's value can be 0, 1, 2 and i's values can be 0 to n minus 1. And this is done. So now I would say that dp of 0 cross 0 is equals to color of 0 cross 0. See, I is equals to 0, c is equals to 0, color of 0 cross 0. Just match it with this thing. Okay, I is equals to 0, c is equals to 1. Okay, so I would say dp of 0 cross 1 is equals to call of 0 cross 1. And then I would say dp of 0 cross 2 is equals to call of 0 cross 2. 0 cross 2 is equals to 0 cross 2, 0 cross 1 is equals to 0 cross 1. So whenever you're not understanding the tabulation approach, make sure you write the memoization or recursive approach so that you can relate why I am writing this, why I'm writing that. So now we would start the for loop. So for int I is equals to 1, I is less than n and I plus plus. Okay. And then I would say that dp of whatever be the I, and if it is 0, if c is equals to 0, then what is the cost? Minimum of I minus 1 of 1 and 2 and color of 0. Like minimum of black and yellow and the cost to paint it with pink. So I would say minimum of dp of I minus 1 comma 0. If we have 0, we would have 1. And if we have dp of I minus 1 of 2. If we have 0, then the remaining options are 1 and 2. C. C of 0, remaining option of I minus 1, I minus 1. And then I would say that call of I0. So I would add the value call of I comma 0. Simple enough. And then the same thing would happen for 0, 1 and 2. If we have 1, then the remaining options are 0 and 2. And the cost to paint it with 1. If we have 2, then we have the cost to paint it with 0 and then again 1. And the cost of painting this would be 2 itself. And then whatever Asta Tripathi was telling, the minimum of all of this, and then we would say that return the minimum of dp of n minus 1 comma 0, and then dp of, okay, dp of n minus 1 comma 0, and then dp of n minus 1 comma 1, and then dp of n minus 1 comma 2. So this is how you can just relate with the top. All the condition written here are can be related with the top one. Now let me see how many mistakes I am making. I'm making correct decision. Okay, so I'm correct for the given one. So see, never directly. So if you are not very good with dynamic programming, so if you came here, that means you're not good with dynamic programming. So what I would suggest you to do is that first write the recursive approach so that you would understand when to write what, because this seems easy but little difficult to think and write. But to think and write this one, it seems more logical. So write the recursive code, then derive the recursive code, like write the recursive one and then derive the iterative from it. Am I clear to you? Give me a quick one if this long explanation was needed. So can you look my code in comment section, and my user ID is user 8. Okay, absolutely, I would see to it. And would review it user 8. If it is upwards, user 8. No, it is not upwards. So I need to search a lot. So tell me the point at which you are not able to understand. Just tell me the line number and that would be fine enough. Just quickly tell me the line number at which you are not able to understand. So I think a lot of waiting has been done. So that was it from my side. So if you're watching this stream in the recorded version, feel free to like and comment on the video so that the reach of this video could be increased and this hard work could be justified. That's it for today. Thank you and have a nice day. Good night, everyone.